Good morning, class. Again, I'm sorry I cannot be there. And like I said, you guys are not going to miss instruction. I want you guys to stay on track. So today we're going to be talking about the different solutions to linear equations. And we briefly went over it on the first day of class, where we mentioned what it would look like on a graph if a system had no solution or if it had one solution or infinitely many solutions. So we're just going to review that. And I kind of wanted to go over the note sheet just to give you guys a better idea of what that meant in terms of a system. So what's bolded is what you need to fill in or underline and highlight. So I want you guys to be following along, taking notes. And then at the end, you have a big ideas to complete and turn in. Whatever you don't finish in class is homework. And I hope you guys all did your bell work because I grade that. So the solution of an equation is the value or values of a variable that make the equation a true statement. So remember when I talk about seeing if a system is true. So that means you get something at the end that makes sense. Like say if 3 equals 3, that is true. You know for a fact that 3 in fact does equal 3. Equations in one variable can have one solution, infinite solutions or infinitely many solutions, or no solution. So let's fill out that chart. So I'm going to start with the first column, and then we're going to go row by row. So right now we're going to be talking about one solution. Okay. So for one solution, the reasoning, what the type of solution means. So for one solution, only one value. Oh, it's telling me right. Only one value will make the equation true. So one number will make the equation true. Okay. Again, if you need more time, just pause the video or rewind it. And then we want to know if it's a true solution always, sometimes, or never. For one solution, it is true sometimes. So if I'm writing, you're writing, and make sure you're writing in the correct location. A conditional equation is true for some values of x, so only true one time. Only true one time. So for one solution, that solution is true sometimes. Conditional equation is true for some values of x. Okay, let's keep pushing through. Now let's go over an example. So let's solve this equation. And like you guys are familiar, we're going to get x by itself. So 4x equals 12. Then we're going to divide both sides by 4. And x is going to equal 3. So we only have one solution to our equation. So 3 is the only number that makes the equation true. So that means it's one solution, and that one solution is 3. So like I said, this is a review. I just wanted to give you guys a helpful note sheet to review this. If you need more time, pause it, rewind it, do what you gotta do. And make sure you're writing this in the correct spot, please. So now let's get some hints, some helpful hints. So the end result still has a variable and a solution. So if you look in the row before it, we saw that x equals 3. It was one solution. So we see a variable and a solution. That's how we know that it is one solution. I'm only erasing so it does not continue to the next slide. Do not erase your paper. Okay, so now we're going to go to the next column. We're talking about infinite solutions or infinitely many. Okay, so there is any value that will make the equation true. So any number will make that equation true. And if you remember in the beginning of class, that's when we saw a graph that overlapped. That's kind of ugly, but you get the point. So that's one line, and then the other line completely overlapped. So that means they shared each and every point. So any number would make that system true, or any number would make that equation true. Okay, we want to know if infinite solutions are true always, sometimes, or never. And they are going to be always true. They're always true. An identity is always true for any value of x. So they're true every time. Every time. For infinite solutions, they're always true. An identity is always true for any value of x. True every single time. Now let's go over an example. So we know how to solve for x. Let's do it. Let's subtract 15 from both sides. I did not mean to put that there. So now we're left with 5x equals 5x. And we're going to divide 5 from both sides. So x equals x. Right? So any number for x will make that equation true. So if I plug in 1, 1 will equal 1. If I plug in 2, 2 will equal 2. It's going to be true for any number, and that's for infinitely many solutions. So that's when your end result ends up looking something like this. That means there's infinitely many solutions. They should be familiar, so I'm pretty much breezing through it. This is just a helpful little table that I want you guys to refer back to. So the hints, variables cancel each other out and both sides of the equation look equal. So we saw that 5x, I think it was plus 15, equals 5x plus 15. We see that the coefficients and variables are the same sign, they're both positive, and we see that there's both a positive 15 on both sides, so both sides are equal. Variables cancel each other out. You see that if we subtract 5x, they're going to cancel out. And then you see that 15 would equal 15. So both sides are equal. You can see that by looking at the equation. Okay, great. Let's keep pushing. Like I said, this should be very familiar. But if you have any questions, email me. I'll be happy to answer. And now we're going to be talking about no solution. So no solution is when no values will make the equation true. So no number. No number. So we had one solution, infinitely many, and now we have no solution. So no solution, no number will make that equation true. Okay, so we want to know if it's true always, sometimes, or never. And that's true never. It's never going to be true. A contradiction is never true for any value of x. So not true ever. Not true ever. It's never going to be true. And let's look at an example. So if we subtract 4x from both sides, what are we going to be left with? 8 equals 3. Does 8 equal 3? No, it does not. So that is not true. It's never going to be true. So no number for x will make the equation true. There is no number that will make that true. So 8 will never equal 3. Let's get that helpful little hint. Variables cancel each other out, like we saw in the last example, and both sides of the equation do not look equal. So we can think back to that last problem or look back on your paper. If we subtract 4x from both sides, we would be left with 8 equals 3. So the variables canceled out. And both sides of the equation do not look equal. This is not a true statement and will never be true. So then you should have another sheet or on the back of your sheet Yeah, it's on the back of your sheet. We're going to continue with our notes. And we're just going to go over some examples and just look more into what these definitions mean. So, for one solution, oh, I forgot to erase something. Okay, so for one solution, the variable terms are different. That's one indicator that it's one solution. The variable terms are different. So we can solve this and see. So 3x minus 5 equals 7x plus 3. Subtract 3x from both sides. We have a negative 5 equals 4x plus 3. Subtract 3 from both sides. Negative 8 equals 4x. Divide by 4 from both sides. Negative 2 equals x. And would you look at that? One solution. So the variable terms are different. Okay, so then we're going to look at infinitely many solutions. So for infinitely many solutions, the variable terms are the same and both sides are the same or equal. So the variable terms are the same. And if we subtract 4x from both sides, we're going to get 2 equal to 2. So both sides are equal or the same. And this is a true statement, so that means it's going to be true for any number, infinitely many solutions. So that's the simplified equation. You see that the variable terms are the same and both sides are the same or equal. Now let's look at no solution. So for no solution, we're going to see that the variable terms are the same, but both sides are not equal. So if we were to subtract 8x from both sides, we would get 9 equals negative 5, but that is not true. So it is not a solution. It's not going to be true for any number. And now we're going to practice. Okay, so in the problem, it's going to ask us to distribute. We see a 2 in the parentheses on the outside, and then we see a 5 in parentheses on the outside. So that's telling us that we're going to need to distribute that 2 to every single term inside the parentheses. Automatically, I'm starting to notice something. So if we look back at our table, I see that our variable terms are different. So that's going to indicate that we have one solution. So let's go a step further and actually start solving this. I'm going to subtract 8x from both sides. Ooh, yeah, my back hurt. So we're gonna have 10 equals 2x plus 20. Now we're gonna need to subtract 20 from both sides. We get negative 10 equals 2x. And what are we gonna do? What are we gonna do to get x by itself? Yep, divide 2 from both sides, so x will equal negative 5, and look at that. We have one solution. So once we simplified both sides, the variable terms we saw were different, and the equation was able to be solved for x. The equation had one solution. One solution, and that meant that negative 5 was the only value for x. That made the equation true. Y'all have lines? I'm running out of room. Just write on your lines. Okay. Pause it. I'm about to erase it. Okay, so yeah, this is the next problem. I see some parentheses. It looks like we're going to do some simplifying. So we're going to distribute that 2 to both terms. We're going to get 10x plus 8 minus 11 equals 4x. Distribute that 3 to both terms. So plus 6x minus 3. Because that was sloppy. Okay. So now we're going to have to simplify both sides of our equal sign. So 10x and then a positive 8 minus 11, negative 3 equals, and then we're going to simplify and combine our like terms on our right side. So 4x plus 6x is 10x minus 3. Automatically, I see that both sides of our equal sign are equal or the same. So once we were able to simplify, simplify both sides, we saw that the variable terms are the same and both sides are equal. This means that the equation has infinitely many solutions. This is hard. So the solution means that any value for x will make the equation true. This is getting sloppy. Equation, that's a Q. I know y'all gonna get on me. True. Pause it. I'm about to erase. Remember, if you have any questions, just email me or write it down and ask me on Friday. And also, y'all better have done your homework from yesterday. I'm not playing. Okay, let's keep pushing. So here, I'm gonna let you guys work this out. And tell me if this has one solution, infinitely many solutions, or no solutions. So I'll give you time to work it out. Okay. So you should have simplified this. This should be you checking your work. Remember, combine those like terms. So we simplify both sides of the equation. This is as simple as we're gonna get. We're simplifying. And remember, if we were to subtract 11x, if we were to cancel out those variable terms, we're going to get 18 equals 7. And that is not true. 18 does not equal 7. So the variable terms were the same. But both sides are not equal. The equation has no solution. And the solution means that no value of x will make the equation true. If I'm writing, what are you doing? I hope y'all been writing this whole entire time because this note sheet is to help you. So no value will make that equation true. That's the end of your note sheet. I hope you have everything written down. Like I said, you could have paused the video if you needed to write something down. But what is due is big ideas by the end of class. If you do not finish it, it is homework. But you should have more than enough class time to finish big ideas. Please do not do anything crazy. Like I said, the sub will and can write down your name. And if your name is written down or anyone's name is written down, you guys will have assigned seats from Monday. But have a great rest of your day. I can't wait to see you guys. These video lessons are not the same. Honestly, quite boring. But I'll see you guys on Friday.